Let's look at a question that's actually pretty interesting and practical. Let's say you're working in a lab and you have a spill. And what you have is nitric acid, and you have quite a bit of it, 2.5 kilograms of nitric acid. And you know it's pretty strong acid. So the first thing you do is you try to neutralize it, and you remember that you can use something like sodium carbonate to do that. And so you take some sodium carbonate from the shelf, about 2 kilograms, and you spread it over the area, and you allow them to react and neutralize each other, and you actually make some CO2 in the process. Question is, was there enough sodium carbonate around to neutralize all of the acid that was spilled? Okay, and so first thing we should do before we answer this question is really try to balance the reaction and see what's going on. So here's the balanced chemical reaction. Okay. So I have nitric acid, which is HNO3, and sodium carbonate, Na2CO3. These are going to react with each other in a double replacement reaction to give me sodium nitrate plus carbonic acid, but that's going to break apart pretty quickly into water and carbon dioxide. Now, if I want to balance this, I need some coefficients. So notice I have 2 sodiums on the left, only 1 on the right, so I'll multiply this by 2. But now that gives me 2 nitrates, so I need a 2 in front of that, and now everything should be okay. All right, so the next thing I want to do is figure out the number of moles of each of the reactants, so for the nitric acid and for the sodium carbonate. So first, for the HNO3, the molar mass I can get from the periodic table. So here's the periodic table. I need hydrogen, which is 1, nitrogen, which is 14, oxygen, which is 16, and later I'll need carbon there, which is 12, and sodium, which is 23. Okay, so now go back here, and I can say that the molar mass of hydrogen is 1, molar mass of nitrogen is 14, molar mass of oxygen is 16, times 3 because I have 3 of those. So if we work it all out, I get about 63 grams per mole. And now I can find the number of moles of HNO3, nitric acid, by taking the mass, which is 2.5 kilograms, so times 10 to the 3 grams, and dividing by the molar mass, 63 grams per mole. So now this gives me about 39.68 moles of HNO3 that were spilled. Now let's compare this to the amount of sodium carbonate that was used or added. So first I have to figure out the molar mass of sodium carbonate. So I have 2 sodium atoms, each of which has a mass of 23, plus 1 carbon, which is 12, plus 3 oxygens, 16 each. So if I work this out, this gives me about 106 grams per mole. And now to get the number of moles of sodium carbonate, take the 2 kilograms, which is 2,000 grams, divide by the molar mass of sodium carbonate, which is 106 grams per mole. So if I work this out, I get about 18.87 moles of sodium carbonate that were added. And the point is, I can't compare this number and this number because that's like comparing apples and oranges. I have to compare the same substance. So what I really want to do is convert the amount of sodium carbonate that I have to how much nitric acid that would be able to neutralize. And to do that, I really have to look at the balanced chemical reaction. So for every 1 sodium carbonate, I'm able to neutralize or react 2 nitric acids. So if I multiply this number by 2, that'll tell me the number of moles of HNO3 that I could have theoretically neutralized. So 2 times 18.7 is 37.74 moles of HNO3 that could have been neutralized And then if I compare the amount of HNO3 that I actually had, 39.68, to the amount that I was able to actually neutralize, 37.74, I realized that I was not actually able to effectively neutralize all of the HNO3. I still have some of the nitric acid remaining. So no, not enough sodium carbonate was added.